put this a bit more steady. Yeah, there we are. So Tijmen is not here. I'll do my best, but he is on the picture there. And the title of his MSc thesis was Projections of Relative Sea Level Rise and Land Subsidence in the Gulf of Thailand. And he proposed this as a bias-corrected approach, where he essentially took the data from the tide gauges and tried to correct the global sea level estimates of a model intercomparison project to have a more localized analysis of sea level. And now I need a clicker. You need to take the picture again, Wim. And as everyone, I have an agenda for the presentation. I'll give an introduction of Tijmen's work, historical sea level analysis, and then we'll try to have a look into the future. But of course, these are just projections. And actually, what Tijmen did is he looked at the sea level, but then the ultimate aim was to project or forecast the mean high water line. Actually, that was turned out to be much more tricky than we thought, but I'll show some hand-waving results, which could form the basis for future research. Who knows? But first, just I think this is all very much known to you. Just the basics in terms of sea level rise. We have contributions of meltings of glaciers, as shown in this picture. Of course, also from the SMA explained from land ice. That's the next one, melting of polar ice sheets. And then thermal expansions. Those are the main contributors to sea level rise. And we can observe it, as Mark also illustrated quite nicely. This picture is a bit a simplified version of what Mark showed. We can observe this with satellite altimetry and with tide gauge stations. And the tide gauges is what forms the basis of the work of Tijmen. Then subsidence or subsidence, depending on your accent, is typically caused by the removal of a fluid, a change of pressure, pore pressure, and that can be oil or gas, as we have in the Netherlands, in Groningen, but in the case of Bangkok, it's typically water, and sometimes we also see mineral resources being produced, and that also can cause downward motion. We also have other geophysical processes, such as earthquake, soil compaction, and glacial isostatic adjustment. The measurements of subsidence, well, INSAR, we've seen a couple of presentations today, and the GPS measurements, as Wim showed them, are of course also very important. And there's a nice animation that Tijmen found. There is also a very interesting study here by the city's climate leadership group. That actually did an analysis of various cities that are at risk because of sea level rise. And I think this is London, not Amsterdam, so we're still safe. But of course, here in Southeast Asia, there are multiple cities at risk, and I see some people in the room nodding. And that's why that's motivated us to do this work. The research area is for this work is then the Gulf of Thailand. Well, you've seen this all before, and Tijmen particularly looked at the Samut Prakan province, and he realized that in that province we have agricultural farmlands, a lot of fishing farms. There's a mangrove forest, but we also are close to urban areas. The temple has been shown before by Wim, and the subsidence, the current estimated subsidence, is around 1 or 2 centimeters per year, and the contributors to this sinking are the compaction of clay, as well as the groundwater extraction, but that comes together with sea level rise. And this introduction, where I don't think there's much new to you, led Tijmen to the research question of how will relative sea level rise, considering both the uncertainties in climate change and the uncertainties in local land subsidence, affect the coastline. But as said, this question was a bit more challenging than we initially thought. Tijmen came up with quite a complicated workflow, and I will take you through that step by step. So the first part was really to analyze historical relative sea level data, and that was based on the tide gauges. And then he corrected the series that he got from global climate models using those tide gauges. And he compared it with altimetry to see whether actually his results made sense. And then he used a digital elevation model to actually estimate coastal scenarios. The historical sea level analysis was done with tide gauge observations, and he selected 4 tide gauges where actually this Ko-Shishang tide gauge only had limited data. And the period he looked at was 1940 to 2022, so quite a long series where he had monthly data. And then for the global climate model sea level analysis, he took the CMIP5 model into comparison project, and MA kindly helped us with that. That's a comparison of 12 climate models, so he could provide an analysis for each of those models. And as it's a pretty coarse model grid, that gives us the sea level analysis at 11 geographical positions, which are indicated here. The period for those models is almost as long as the tide gauges. It's from 1900 to 2015, and that series has only yearly data, so not monthly, but yearly. But using the tide gauge data, he actually constructed a monthly data set from this yearly data set. Showing you how the tide gauge data looks like. As you see, it's quite noisy. But that's also because it's not all noise, it's also a signal, because there are these yearly signals, and since these are many years, you can actually see them going up and down. And as a first step in his analysis, he made everything relative to the year 2000. And the reference frame, I think this is a bit similar to the plot that Mark showed you, is where he actually defined the reference level and then looked at how the different tide gauges were measured and referenced them all to the same level. And when you do that, you actually get a bit less noisy time series, where you start to see certain patterns. Some tide gauges have a bit more of a sea level rise signal, and others seem to be a bit more stationary. And as said before, the Ko-Shishang only has a limited data point. Then the model data sets, we have 12 different climate models here. Each of them has a different resolution, but the climate model into comparison project comes with a product that has this coarse resolution that you show here. And that, of course, gives you a very smooth image of the sea level in the Gulf of Thailand. Then, in terms of the time series, if you look at one single point shown here, you see that all of them tend to have sea level rise, but some of them have more sea level rise than others. So in order to have one single reference level to compare, he processed these data, and he came up with the sea level rise and the sea level variations relative to the sea level in the year 2000, shown here for this point in the Gulf of Thailand. And now is the actual work of Tijmen is really to take the tide gauge time series of these four tide gauges and combine them with the climate model analysis. And he did this using a distance-based interpolation. He computed the bias in the data and he performed a bias correction. And then he scaled the variance in accordance to the data in the model. And I won't go into the technical details of that, but I would be happy to share that if you have questions. And if you look at the result from this, and this is a point, again, the same point over here, then you can see that for one of the models, this is the Canadian model, you can take a period where these points are yearly data, but then by combining it with the tide gauge data, you can actually get a seasonal cycle. And this amplitude is then based on the variance and the data from the tide gauges. To verify his results, Tijmen compared it to tide gauge data. He did not use Mark's data, but instead he used the Copernicus data, and he essentially compared it to data from topics JSON, satellites, and VSATs. And here's a time frame to show you that by combining the different data sets, we have a continuous altimetry data set. When you do so, you see that for this location, this was the location that I've been showing in the previous slides, we actually get a pretty good agreement between altimetry and the reconstruction that Tijmen made. And if we go look more in C, so this is a point over here, then we see that the comparison is not so good. I discussed briefly with Mark, it could be something about inverse barometric correction, but it could also be some other effect. But for me, this is an interesting aspect of the work of Tijmen that we could look into in more detail. Then, using those sea level analyses, Tijmen also looked into how would, and using the results of Jenny, Tijmen looked in how would the subsidence and the sea level together result in a change of coastline. And here I have to make a bit of a precautionary note because the data that we use are all very limited. First, for the sea level analysis, he used different IPCC scenarios, and these are actually similar to what was shown before in terms of different scenarios. Like the blue one is if we are really low on the carbon emissions, and the red one is a more pessimistic scenario. And then he looked again at those 11 locations in the Gulf of Thailand, and for this point that he has been looking at before, you see that when you then use those analyses that he had with the annual cycle, we see different projections over time, but both of them clearly go up. Now the interesting part comes when you start to combine this with the subsidence scenarios that Jenny has been looking at. But before we do that, we use a coastal topography map. This is a different DEM, digital elevation model, than the one that Isabel just used. It's developed by Climate Central, which is a small company in the US. And they used ISAT LiDAR data combined with the 21 DEM model to construct this map. Now you see 3 locations here of the well nests that Jenny has been using. And based on the groundwater estimates there, we can also model subsidence. So that is what Tijmen has been doing, and then he took different scenarios for the to look into the future, and then you can actually model, or or these are 3 different locations, but he also looked at different scenarios. But for one scenario, he has these 3 subsidence profiles based on the location. So you see more subsidence here in the west and less subsidence in the east. If we look in the west, and the location of the wellness is really inland, but Tijmen extrapolated that towards the coast, he came up with this subsidence profile. So each line is a different, relates to a different point here on this, in this set of 5 measurement points. He did the same for the more eastern point, and he did the same for the point that is close to Bangkok. And you can already see that this last point, there was the very little subsidence. And when you take those analyses and you combine them, or you look at the land deformation based on that, and again, it's very much extrapolating the work that he did, or extrapolating the scenarios that Jenny computed, then you see some land deformation here for A, depending on the latitude, and the same here for B. So depending on the vertical coordinate, you see a different subsidence profile. And when you combine this with the sea level analysis, and that's the last step, then you can actually see how the DEM would change if that sea level would change within those, if the subsidence would change within those polygons that Tijmen defined. And again, this is very hand wavy, and this is, you can already see the blocks of those polygons, but it's just to illustrate that suppose the world would be square and we would have those polygons, then this part would easily be flooding if the subsidence scenarios are true. Again, this is very speculative, but it's just to, and I see some people nodding here, but this is just to illustrate what if would happen if this is the subsidence. And I don't think it's bringing much news, but I do think there is a lot of interesting material in here to perform a more detailed analysis. With these very preliminary results, the conclusion of Tijmen was that it's clear that the majority of the low-lying agricultural land in Samut Prakan is at risk if the subsidence estimates of Jenny for the different scenarios are actually working out the way that Tijmen modeled this. What we see is that the differences between the different scenarios that Tijmen modeled, and this is not shown here in the presentation, but what he actually found is that no matter which scenario you take, you always get a lot of flooding. So this is in a way telling us that this area is quite at risk for flooding. And Tijmen's suggestion was also, and I think this is also music to your ears, to also look at the socio-economic impact of these results. But this is really not our domain, but I do think it's important to look at that. And with that, I would like to open the floor for any questions that you may have. Wim suggested that Mark has a question, but Mark doesn't have a question. He doesn't dare to. Anyone else? Or are people ready for drinks and dinner, perhaps?
I can ask one question, if it's possible.
Yeah, we hear you. That's Philip, right?
Yes, it's me. Hi. Yeah, I may have missed it because I missed one bit, but how are let's say, the scenarios being treated? Because it's a mix also with the influence of groundwater extraction scenarios. And do you also consider that the compaction or the subsidence may happen from other causes, like shallow compaction components? Is that something you were able to split in these projections?
As far as I know, but Jenny knows more about it. I think it's only groundwater scenarios. Yeah, Jenny is nodding. So we did not look at any other sources of compaction, and that would, or subsidence, that would only increase the bandwidth, I would say. But this is perhaps where your model could also help a lot, Philip.
Yeah, and then the observations are from INSAR, reflectors at the surface.
No, the observations that, well, the projections, we don't have observations, right? But the observations for the past was really based on the sea level, so the tide gauges. It was only the, let's say, the wet part of the changes. And I'm now looking at Jenny for your subsidence modeling that was initiated with from the groundwater modeling. Yeah, but Tijmen only used the projections, is what Jenny is saying. Does that answer your question, Philip? Yeah, but
sorry for having missed it, but I think indeed that, then natural compaction will even come on top of that.
Exactly. Yeah.
Okay, thanks.
Thanks for that. If there are no more questions in the room, then I would like to invite Milan, if he's online.